From molten metal to precision steel and grinding balls, witness the artful forging and rolling shaping tomorrow's strength today. The open die forging process on a 4,000-ton hydraulic press begins with heating the steel ingot inside a furnace until it reaches forging temperature, ensuring uniform softness throughout the material. Once the correct heat is achieved, operators transfer the glowing ingot to the press using overhead cranes or manipulators. The ingot is then positioned between the flat dies of the open die press. As the 4,000-ton press applies downward force, the ingot is gradually compressed and elongated. During this stage, the operator repeatedly rotates and repositions the workpiece to promote even deformation and refine the internal grain structure. Next, drawing and upsetting sequences are performed. The press reduces the cross-section to extend the length, or shortens and thickens selected sections to meet dimensional requirements. Throughout the process, the forging is reheated whenever its temperature drops below the allowable forging range. After achieving the required shape, the operator performs final planishing strokes to improve surface quality and achieve tighter tolerances. The forged piece is then transported to a cooling area, where controlled cooling helps relieve internal stresses. Finally, the rough forging proceeds to trimming, heat treatment, and machining, completing the open die forging cycle on a 4,000-ton press. Open die forging, as demonstrated by Summers Forge, is a highly controlled process in which heated metal is shaped between flat, open dies without fully enclosing the material. First, the steel is brought to forging temperature, then placed on a stationary lower die or anvil. A powerful hammer or press delivers successive blows, gradually deforming and elongating the workpiece to achieve the required geometry. Throughout the process, the smith constantly repositions and rotates the billet to ensure uniform shaping and refined grain structure. Summers Forge applies this method to produce custom components ranging from 1 kilogram to over 80 tons for demanding sectors such as mining, oil and gas, and heavy engineering. With integrated heat treatment, machining, and testing facilities, the company completes each forging to precise specifications and consistently high quality. In this forging operation, a heated steel ingot is positioned beneath a massive hydraulic hammer, glowing bright orange as it reaches forming temperature. A manipulator firmly grips and rotates the workpiece, allowing the operator to present each surface accurately to the hammer. With every controlled stroke, the metal is compressed and reshaped, gradually transforming into the required heavy-duty component. The hammer's powerful blows refine the internal structure, improve density, and eliminate defects. Throughout the process, the operator coordinates movements, ensuring correct alignment and uniform deformation. This precise open die forging method enables the production of robust parts weighing up to several tons. The 13,000-ton open die forging press is a monumental piece of heavy industrial equipment engineered for shaping large steel ingots with exceptional force and precision. Manufactured by SMS Mir in September 1982, this 4-column, push-down, water hydraulic press remains one of the most powerful machines in the forging sector. Its robust construction allows it to withstand continuous high-load operations while delivering controlled deformation of heated metal. With an impressive capacity of 13 meganewtons, 13,000 tons, the press can forge massive components required in industries such as power generation, shipbuilding, oil and gas, and heavy machinery. Its generous dimensions further enhance its capability. The machine offers a maximum press stroke of 500 millimeters, providing ample vertical movement to work on large billets through multiple reduction and shaping steps. Additionally, its daylight of 8,000 millimeters allows operators to handle tall or bulky workpieces with ease, improving process flexibility. The press also features a substantial distance between columns 6, 750 by 2, 650 millimeters, giving wide workspace access for manipulators and handling equipment. This structural layout ensures stability during extreme forging loads while maintaining precise die alignment. Overall, the 13,000-ton forging press stands as a testament to advanced hydraulic engineering, enabling the production of high-strength, high-integrity forgings essential for demanding applications. NuScale power and Doosan interoperability have entered a pivotal phase as production forging begins for the first NuScale power modules. These factory-built units, including their containment structures, are manufactured entirely off-site and then shipped directly to the plant, eliminating field fabrication and reducing both project costs and schedule risks. This milestone marks a major step toward commercialization, ensuring NuScale remains on track to meet customer and project delivery commitments. With this progress, NuScale continues advancing its mission to provide the carbon-free energy essential for a sustainable future for all. The steel production process at Georgsmarienhütte begins with the preparation of sorted scrap, which is meticulously selected to ensure consistent quality. This recycled material forms the main input for their electric arc furnace, where intense electrical energy melts the scrap into liquid steel. Once fully molten, the steel is transferred to secondary metallurgy, a critical refining stage in which temperature, composition, and cleanliness are precisely adjusted. Throughout this phase, samples are taken at different points to verify chemical accuracy and guarantee that each steel grade meets customer specifications. After refinement, the steel moves to continuous casting. Here, the modernized casting machine forms the metal into 6 strands, producing billets with uniform geometry and structural integrity. These billets then enter the rolling mill, where advanced rolling stands shape them into bar and long steel products. Precision rolling units enable the production of extremely accurate diameters, while 3-disc stands ensure tight tolerances and allow quick adjustments to rolling dimensions. This flexibility shortens production times and supports a wide range of product sizes. Following rolling, the bars are cut to customer-defined lengths with high accuracy. Quality checks are performed continually, ensuring that dimensional, mechanical, and surface requirements are fully met. The finished steel is then prepared for shipment using streamlined logistics systems that deliver products exactly when required. Through recycling, precise metallurgical control, continuous casting, and automated rolling, the plant consistently produces high-grade steel tailored to demanding industrial applications. The manufacturing of oversized seamless rolled rings and heavy-walled shells begins with selecting high-grade steel ingots, which are heated in ultra-low-emission natural gas furnaces. These furnaces, featuring capacities up to 10,000, 8,000-4, 500 millimeters and temperature uniformity within plus or minus 5 degrees Celsius, ensure controlled heating for SA508-3 and other critical alloys. Once the ingot reaches forging temperature, it is transferred to the 13 500-ton open-die hydraulic press, which provides a 7,000 millimeters headroom and a 5 800 millimeters opening. Under this immense pressure, the ingot is drawn out, upset, and pierced to form a hollow preform, suitable for ring rolling or shell forming. For large reactor pressure vessel shells measuring 200 times E4, 600 times 3,000 millimeters, and weighing up to 105 tons, the press shapes the wall thickness and geometry with high accuracy. When producing seamless rolled rings, the pierced preform is moved to the 16-meter diameter ring rolling mill, capable of handling rings up to 16,000 millimeters, with heights reaching 3,000 millimeters. Here, radial and axial rolls continuously compress the material, refining the grain flow and achieving exceptional mechanical integrity. After forming, components such as coke tower transition segments or nuclear-grade shells undergo heat treatment in split HT furnaces or large trolley furnaces, 14,000 times 7,000 times 4, 500 millimeter, to achieve the required microstructure. Finally, precise machining and inspection guarantee high accuracy, high efficiency, and reliable delivery for critical heavy equipment applications. Duresttol is a modern, heavy forging specialist whose roots lie deep in the industrial history of the Bergisches Land and the 400-year forging tradition of the Dedricks family. From these origins, the company has developed into one of Europe's largest and most advanced open-die forges, continuously expanding its production halls, workshops, and highly skilled workforce of nearly 500 employees. Today, Duresttol maintains around 30,000 tons of input material in numerous block formats, focusing on engineering steels, alloyed and quenched and tempered grades, case-hardening steels, as well as stainless, acid-resistant, and heat-resistant steels. Its standard program includes more than 100 materials according to German and international standards, with the capability to produce special high alloy grades in close cooperation with customers. Precision begins with sawing the input material to calculated weights on more than 20 circular and band saws, capable of handling diameters up to 800 millimeters, lengths of 15 meters, and individual weights of 35 tons. Heated to 550 to 250 degrees Celsius, the preforms are forged on steam hammers and hydraulic presses. Smaller pieces, up to 500 kilograms, are manipulated by hand tools, requiring exceptional teamwork and craftsmanship, while larger work pieces are handled by electro-hydraulic manipulators. For extremely heavy forgings, 2 4-column underfloor presses with up to 40 meganewtons force shape axles and drive shafts in a single operation. Duresttol also operates 2 state-of-the-art ring rolling mills, producing seamless rings up to 500 millimeters in diameter and 8 tons in weight, with tight tolerances and optimized material flow. Heat treatment, performed in 33 furnaces with modern burner technology, imparts the required hardness, strength, and toughness through quenching, tempering, normalizing, or solution annealing. A fully equipped 9,000 square meter machining shop delivers precise turning, milling, deep hole boring, and carousel machining for parts up to 35 tons. Comprehensive ISO 9001 certified testing, including ultrasonic inspection, tensile and impact tests, and spectrometric analysis, ensures full traceability and reliability. Supported by an automated high bay warehouse and a dedicated logistics fleet, Duresttol supplies sophisticated forgings for applications ranging from wind turbines to heavy machinery worldwide. The manufacturing process of tower components at Gargala Group follows a streamlined and fully integrated process. First, steel bars are laser cut to high precision before being transferred to advanced welding stations for structural assembly. Inverter welding is applied to ensure strong and uniform joints on all sections. Next, panels are produced and trimmed on a vertical cutting line to achieve precise dimensions. After shaping, each part is taken to the powder coating shop where a durable protective finish is applied. Finally, the components are assembled in a dedicated installation area, completing a solid and precisely engineered tower structure, ready for installation. At the Bevel Gear Workshop, we are equipped with 10 of the most advanced CNC bevel gear cutting machines, including C60U, C100U, and GMC 160, all from Klingelnberg, Germany. Several high-precision bevel gear testing machines, such as GKP851 and T200, along with measuring instruments P100 and P350, ensure top-level inspection. Our GMC 160 CNC machine is capable of processing large spiral bevel gears up to 500 millimeters in diameter, using dry cutting to save energy and protect the environment. After soft cutting and heat treatment, hard cutting eliminates distortion and achieves surface roughness as low as raw 0.4, reducing transmission noise and extending gear life. With advanced testing and measurement systems, we maintain world-leading precision in spiral bevel gear production. Modern Forge, a fourth-generation family-run company, operates facilities with over 35 production units and a workforce of 500. Specializing in alloy, carbon, and stainless steels, they produce shafts and precision parts for major markets. Their unique cross-roll forging process creates shafts up to 4 inches in diameter and 31 inches long, using 28 hammers, including 9 high-speed automatic units, plus robotics for faster production. The plant features 5 forging presses, 600 to 4,000 tons, precision trim systems, cold coining, heat treating, machining, welding, and coating. Partnering with clients, engineers ensure accurate, cost-effective parts with rapid speed to market and predictive manufacturing software, all under ISO, AAAS, and HR certifications. The steel grinding ball manufacturing process begins with the selection of steel bars to achieve the desired hardness and wear resistance. The sorted steel is melted in an electric arc furnace, and alloys are added in a bucket refining station to adjust the steel's properties. Shaping is then done by forging, casting, or precision rolling to form uniform spheres. After shaping, the bowls are heat-treated, which includes quenching in water or air to harden and tempering to increase toughness and impact resistance. In the finishing stage, grinding and honing refine the shape and surface quality. The balls are then thoroughly cleaned and rigorous quality control, both automated and manual, ensures they meet strict standards for hardness, wear resistance, and dimensional accuracy before being packaged and shipped worldwide. A rated grinding material, part of the IA group, specializes in the production of high-quality grinding materials, including steel balls, PEPs, and grinding rods. Each product is carefully manufactured and rigorously tested to ensure superior wear resistance, efficiency, and environmental performance. The company has contributed to drafting 6 industry standards for forged and rolled steel balls and holds over 20 patents, earning recognition from world-renowned mining enterprises such as China Minmetals, China Nonfer Metals, China Gold, Zin Mining, Rio Tinto, and Vale. Quality is the lifeline of the enterprise. High-quality steel balls play a critical role in grinding, effectively reducing cost and energy consumption. To support innovation, the group established the IA Advanced Materials Industry Research Institute in cooperation with the Institute of Metals of the Chinese Academy of Sciences, focusing on R&D, material preparation, and customized solutions. Raw materials undergo strict double inspection before entering production. Manufacturing is fully automated, with 15 computer-controlled grinding media production lines ensuring consistent quality across batches. The company maintains ISO 9001 certification and employs 360-degree dynamic control management software to monitor every production stage. With an annual output of 300,000 tons, advanced logistics, and dedicated customer service teams worldwide, Irata grinding material ensures timely delivery and reliable support. Combining technological innovation, high efficiency, and customer-focused service, the company continues to lead the grinding material industry. The drive technology used in steel-making plants and rolling mills must meet the highest demands. Sturdy and reliable drive systems are essential to ensure top-quality products and maintain high plant availability for decades. SMS SEMA has specialized in the development, design, and manufacturing of drive systems and components, combining metallurgical plant and rolling mill process know-how with modern gear design to achieve optimum drive solutions. SMSC Mug's product range includes all drive systems for hot and cold rolling mills, as well as steelmaking plants. For rolling mills, SMSC Mug supplies main drive gears, mill pinion gears, and twin drive gear units, along with drive units for shears, edgers, sizing presses, and coil handling systems. Their flex and slipper type spindles are engineered to handle the highest torque requirements, such as those in BOF converters. Tilting drives are also supplied, with all gear components developed and manufactured in-house at SMSC Mug's headquarters and workshops in Germany. In recent years, more than 80 million euros has been invested to expand the Hiltonbach workshop, including a new gear-making shop where all major manufacturing steps for large drive units are integrated. This allows SMSC Mug to guarantee top quality and short delivery times. Thanks to the modern machinery pool, the company can fabricate gears with a module up to 40 and diameters of up to 6 meters. The production of a large drive wheel begins in the welding shop, where fully mechanized, submerged arc welding is applied to all joints. After welding, the gear wheels are annealed for stress relief, and the tooling is milled using state-of-the-art machines under the supervision of qualified personnel. Case hardening of double helical spur gears weighing up to 45 metric tons and measuring 4.5 meters in diameter ensures durability, followed by ultrasonic testing of the gear teeth. The tooth flanks are ground on profile grinders, and the finished gears undergo high-precision testing on a dedicated gear measuring machine. Gear housings are also produced in-house, and the complete gear units are pre-assembled with the gear contact pattern adjusted using eccentrics. This computer-aided adjustment ensures precise alignment and allows for corrections even after years of operation. The workshops at SMSC Mug and Hiltonbach are among the most advanced in Europe, especially in gear manufacturing. Welding the gutter from the inside is a precise process that ensures durability and leak resistance in roofing and drainage systems. The procedure involves carefully joining gutter sections by welding along the interior seam. This method provides a smooth and sealed connection, eliminating gaps where water could escape. The welder must maintain steady control to achieve uniform penetration and a clean finish, which is crucial for the gutter's long-term performance. Compared to mechanical joints or adhesives, interior welding delivers a stronger bond and greater reliability under heavy rainfall or changing weather conditions. As a result, it is widely used in professional construction and repair projects for metal gutters. The overhaul of the Howden WRV510 compressor begins with carefully draining all lubricating oil to ensure a safe and clean working environment. External connections are then removed, including flange bolts from the suction and discharge ports. If present, the coupling guard and spacer coupling are detached to provide full access to the compressor's internals. Next, the discharge end cover is opened for initial inspection, followed by the removal of the suction end cover. The rotors are carefully extracted, and the thrust bearings are disassembled to allow detailed inspection of the balls and races. Every internal component is examined for signs of wear, damage, or deformation, ensuring that all parts meet the required standards. After inspection, all components undergo thorough cleaning to remove oil residues, debris, or contaminants that could affect performance. Measurements are taken for all journals, bearings, and other internal clearances, using precise instruments to verify that they are within specified tolerances. Any worn or damaged parts are identified and prepared for replacement or refurbishment. Reassembly follows, strictly adhering to the original specifications of the Howden WRV510. Rotors and bearings are carefully reinstalled, ensuring correct alignment and clearance. Suction and discharge covers are replaced, and all flange bolts and external connections are securely fastened. Finally, the coupling and guard are reattached, and the compressor is filled with fresh lubricating oil. This meticulous process restores the compressor to optimal working condition, ensuring reliable performance and longevity.